Welcome back. This is Mr. Tipton, and today we are talking about samples. A sample is something that's called a subset of a population. You know, when you go to Costco or Sam's Club and they hand out samples, they're wanting you to try their product, before you buy an entire box of burritos. Well, let me just take a sample and see if I like it. At school, if you were wondering who was going to be the next student council president, it might be difficult to survey the entire population, so you would just survey a sample of people. Maybe it's people at your lunch table or people in your first hour. There are different kinds of samples that you can take from a population. We're going to focus on 5 different types of samples today. And the first group are called unbiased samples. Unbiased samples are the kind that you want. They fully represent the population. They're selected at random. And a good unbiased sample is also going to be large enough to provide accurate data. You don't want it to be too small because if you survey too small of a group, you may not fully represent the population that you're trying to draw inferences about. There are 3 types of unbiased samples that we're going to look at this year, and the first is called a simple random sample. This is where each item or person is just as likely to be chosen as any other. Okay, names, drawing names out of a hat, or if there was a computer program that randomly generated, an item or a person, those would work. Completely random. Everybody's got the same chance of being chosen as anybody else. The next kind is called a stratified random sample. This is where the population is divided into similar, non-overlapping groups, and then a simple random sample is selected from each group. Okay, I thought this was a pretty good example. 2 students from every homeroom are asked if they are going to the dance. Okay, you want to know how many people are going to the dance? It's tough to ask the entire school. So you just go around to each homeroom and ask 2 people from each homeroom. All right, dividing it into similar groups is the part where you're just asking each homeroom, and then you do a random sample from each homeroom. Maybe then you put the names in a hat. But it's the part about splitting it up into groups that goes with stratified. The third unbiased sample that we're talking about today is a systematic random sample. Items or people are selected according to a specific time or interval. This could be something like every 10th customer that comes through the door, or a customer who's in line is chosen every 20 minutes. Sounds like a long time to wait in line, but you get the idea. Systematic is there's usually some kind of pattern to who is chosen or what is chosen. Now, biased samples are less good because they do not represent the entire population. 2 different kinds of biased samples that we're going to talk about today. The first is convenience. This includes members of the population that are easily accessed. The first 10 people in line. You ask them just because they were the first ones there. That's a little different than the systematic random sample, because that was, that could be every 10th person in line. That's more random than just asking the first 10 people that are there. It's called a convenience sample. Another biased sample type is called a voluntary response sample, and that involves only those who want or can participate in the sampling. Being asked to participate in an online survey. Only people that want to fill out the survey are going to fill out the survey. So you're not really getting opinions of people who don't want to take the time to fill out the survey. Even when your parents go to the polls and they vote for, they vote for the president, for example, that is a voluntary response sample. Nobody makes you go stand in line to vote. All right, so now, what do we do with those different sample types? Well, here's an example of some things we might have to do. It says a pet store mailed a survey to residents to determine their favorite pets. 50 people responded, and the results are shown in the table. Is this sampling method valid? If so, how many people can you expect to choose dogs as their favorite pet in a city with 1,585 people? Explain. Okay, well, so first thing we have to do is, and maybe I'll even underline it here, is this sampling method valid? The answer here is no. No, not valid. Why not? Well, the pet store mailed a survey to residents. 50 people responded. This is a voluntary response survey. No one was forcing them to take it. They just mailed it out to everybody, and only 50 people responded. So it doesn't give us a good, it's not a good representative for the entire population. Oops. Tough for me to talk and write at the same time. Voluntary response. So it's biased. So we're not even going to bother figuring out if, how many people would choose dogs out of 1585, because it's not a good survey. Now, from a batch of 7,500 computer chips produced, the manufacturer sampled every 150th chip at random for defects and found that there were 2 defective. Is this sampling method valid? If so, find how many of the 7,500 computer chips you can expect to be defective. Explain. This one's actually pretty good, I think. Yes, it is valid. Yes, and maybe I should be more specific. Sorry, let me erase this. Actually, yes, it's okay. Yes, it is valid. That's what I'm going to put. Yes, it is valid. What type is it? This is a systematic random sample, because every 150th chip is chosen at random. Okay, that's called systematic ramble. Now, the next part of this, if so, which it is, find how many of the 7,500 computer chips you could expect to be defective. Well, the first thing I'm going to do, if there were 7,500 computer chips total, and they looked at every 150, well, that's going to come out to 50 chips. 50 chips that they looked at out of the 7,500. All right, so I'm going to use a proportion for this. What they found that 2 out of 50 were defective, and so we want to know how many out of 7,500. Okay, nice easy proportion. I should probably double check with my labels. I usually have totals on the bottom. Total that they looked at. 2 were defective. Of course, they're all chips, but we've got defective to total and defective to total. Alright, so cross products, we're going to have 50x is equal to 2 times 7,500. 50x is equal to 15,000. Divide both sides by 50, and x is going to be 300 chips. So we could, we could predict, or maybe even infer based on the data that we have, that 300 chips out of the 7,500 would be defective. Okay, so once we know that a sampling method is valid, we can then make inferences about what else could happen. Kind of like using probability to predict, but this isn't really a probability. We've got actual data taken from a systematic random sample type of survey. One more example. What can you infer about the students at North and South middle schools? And this is just pretty straightforward. Looks like there was a survey done out of 100 students at each school. There are probably more than 100 students in the school, but you never know. Well, it looks like most students at both schools prefer chocolate bars. Prefer chocolate bars. Okay, we're just looking at the information that we have and drawing a conclusion, making an inference. Something else you could put, you could say, about, boy, that was ugly. Undo. About 3 times as many students, a lot of writing, as many students at North, and I'm losing my pen, at North prefer chocolate bars. I'm just going to put CB because I've got too much ink on the screen. CB to gum. And we know that because, come on, 20 times 3 is 60. And that's pretty close to the 65 chocolate bars at North Middle School. So there's different ways you can infer things. All right, so there you go. Different types of samples and what you can do with valid samples as far as making inferences. Make sure you write down any questions that you have, and we'll talk about them next time I see you.